Okay, so let's discuss a question from thermodynamics. Basically, we have a rigid tank which contains 2 kg of N2, okay, and at 25 degrees Celsius and 550 kPa is connected to another rigid tank, okay, and you have a valve in between. So there's another tank that contains O2 and 4 kg of O2 at 25 degrees Celsius and 150 kPa. So now when the valve is open, gas is mixed, the final temperature is obviously 25. Okay, so final temperature is given. Now what is the final mixture? So obviously the final pressure we need to find out. So remember, these are ideal gases and we assume that the mixture is also ideal gases. So initially the N2 is the pressure of N2, Vn2 is mR T. This is R is again the gas constant, and similarly at the initial state of O2 and VO2, because they occupy different volume and the masses are also different, the R is also different, gas constant is given of N2 and O2, and temperature is same. So we use this, okay. And now the final, actually each of the gases in the final state, each of the gases will occupy the entire volume. So the total volume is basically VO2 plus Vn2 initial volume. So once we get this, then once we get the total volume, now the each of the gas at the final state will occupy total volume. So final pressure of O2 into V, we apply now the ideal gas for O2, let's say. So the partial pressure of O2 into total volume into, now we have to use MRT, okay. What we'll do is we'll use nRT, that is number of moles of O2 into universal gas constant into T. We can add M also, there's no hard and fast rule. So M of O2, mass of O2 will remain same, R into T, R of O2. So this is in the final state, okay. So this is final, and now the pressure of N2 final into V into mass of N2, R of N2 into T, okay. So this is all same, okay. Now we need to get total pressure. So to because these are partial pressures, and the total pressure which the tank will be feeling is sum of these two. So that is nothing but MO2 RT plus M N2 RT, R of again this is O2 universal gas constant, this is N2 by the total volume, okay. So we know everything, but we don't know total volume here. So for total volume we need to find out the individual volumes here, and individual volume can be found out by these equations. So let's first get individual volume. So individual volume Vn2 is M N2 R of N2 temperature by pressure of N2. So let's do that first, okay. So mass of N2 is 2, R is given as 0.2968, so 0.2968, temperature is 25, so 298, and pressure is basically 550 kPa, yeah, into 10 power 3. So volume we get as 0.3216, okay. So that is 0.16 550 kPa, and this, I mean, there is no need of 10 power 3 because this R is given in kilojoules, right? So this is kilojoules, so you can have on the left hand side also. So there is no need of 10 power 3, it has to be kPa only, because this 10 power 3 and that 10 power 3 gets cancelled. And now V of O2 initial state is again same, MRT by pressure of O2. So MRT is again mass of O2 is 4 R is let's look at the R, 2598. So 0.2598 into 298 into 150 divided by 150 because it's 150 kPa. So this value comes about 2.065, so meter cube, and this is also meter cube. So now when we sum up these two values, we get about so here we use this expression now, this expression here for V. So V is summing up these two, so 0.3216 plus 2.065, and this value comes about 2.3816. So now when I substitute this value here, so the total pressure, remember that for the final we have again written the ideal gas equation for O2 and N2, and they are individual, and so they occupy, each of the gas now occupies the total volume, and we get the partial pressure for each of the gas now, and then we sum it up to get the total pressure. So this is the expression that gives. So same thing, MO2 is again 4 kg, R is again 0.2598, and the final mixture is again 298. So plus the same thing here, the 2 into 0.2968 into 298 is the total gas by the volume, which is 2.3816. So doing this we get a value of 204 kPa. So this is the pressure. So only idea is basically how do you apply your ideal gas equation. So the answer is 204. And so how do you apply your ideal gas? So initially we just apply ideal gas for N2, ideal gas equation for O2, and finally because they occupy the total volume, so when you consider pressure, each of the pressure of N2 is P dash N2, take the total volume because N2 occupies total volume, O2 also occupies total volume, and temperature is anyhow given. So apply final ideal gas equations for both, and whatever is given based on that you have to find out. So 204 kPa. Thank you.